Welcome. In today's episode, we'll discuss loops in Python and Grasshopper. Let's get started. So let's open up our usual open Grasshopper canvas, and then we will go into the Python scripts and take a look at loops. So let me zoom in a little. And the first loop we want to use is called while. So the while loop is just like an if statement. It says while and then a condition right here, which can be either true or false. So we will start immediately with a numerical example. So we'll do x is 3 and then x is less than 10. So in this case, the condition is true. So whatever it's within the while loop will be executed a certain amount of times. So we'll just print the value of x. Then we'll take x and increase its value by 1. This plus equals is just like going x equals x plus 1 is the same. And then we will just print just the word, which is end right here, so that you can see when the loop is ended. So we can print it. And indeed, if you inspect the console down here, you will get the execution and then the end that we printed outside. So what is happening? We defined x equals 3, then we get into the while, and x is less than 10, which is true. So we get inside the loop, we print the value of x, here it is, 3, and then we increase the value of x by 1, it becomes 4, it goes back to the beginning, so 4 is less than 10 is again true, it's printed out, so here is 4, and so on and so forth, up until when it gets to 9. So then 9 plus 1 is 10. It goes back to the beginning of the loop. 10 is not less than 10. And then it prints out x. Sorry, it doesn't print out x anymore because this is false. So this will be skipped, and it goes to line 7 and then line 8 and prints the end string down here. So we can do the same thing in a different way. We can actually write a while true. While true, don't execute it while it says while true, because it will break your Rhino instance. And then we can define again. We'll print x. Then we will increase x by 1. So I will use plus equals 1. And then we need some sort of a way to break it, because if we say while true and execute it, it will run forever and break the Rhino installation. So we need an if statement in this case, which we saw in the previous video. We can go if x is greater or equal to 10, which at a certain point will be true because we are increasing x by 1 each time. And we will use a keyword called break, and this will just break off the while loop. And if we print that, I did execute it, it's just the same as before. Let's change, instead of 10, let's say 7. You see it's working exactly the same way. This is a little more dangerous to write, especially within Rhino, because if it runs forever, it will just crash the application, which is not great. But it works the same way. You have condition, and then you have stuff inside that at a certain point will trigger a break, and you get out of the loop. So something we can try with this while loop that you can do it's useful is defining an undefined number of iterations, because at this point we could actually we already know the amount of iteration that will happen, because we know that this is 3, this is just 7, this will get increased by 1, so we already know before executing it that we will get 4 execution of the while loop. So since I used 4 executions, you could use the for loop instead of the while loop. And so let's instead define a loop where we don't know before executing it how many times it will be executed. So we will just do x is less than 50. Okay, we will just initialize x at whatever value, which is fine. And then instead of just we'll print it as we did before, but instead of increasing it by 1, we will increase it by a random number. So we'll do x equals x plus, and then random dot randint. We need to import the random module, otherwise that won't work. And let's start with 0, maybe, doesn't really matter. So import random, there it is. So we have random.randint. Randint generates just an integer between the a and b, the parameters we give it. So let's say between 0 and 70. So sometimes it will increase, we will create an integer which is greater than 50, so it will break. Sometimes it will not. We don't know how many times. Okay, and then we can just save it, so Control S, and it will be executed once. In this case, we got 27. We can also actually put the print statement after this, so we can see which one is the number that broke out of the loop. So if I print it, we get 61 immediately. So it breaks up in one iteration. If I run it again by just clicking the green button up here, you'll see that each time the loop gets executed a different amount of time, and you can only do this with the while loop because of the way it's implemented. So this is the while loop. Let's now comment this out and see the other loop we have in Python, which is called the for loop. So it's very similar, but instead of using a condition, it uses arrays to start from. So the syntax is like this: for, then some sort of a word. Let's actually say f in an array. So let's say array. It's actually let's not use array in a whatever. Let's say array. This is the syntax, and what happens is that if we print the value of f, okay, and then we define an array with any content. Let's say I don't know, apple, banana, and kiwi there. Then you see that it prints apple, then banana, then kiwi. So what happens is that it goes in f in the array. F will be within the first iteration, the first value of the array. It will be apple, so it's printed out. Then in the second iteration, it becomes the second element of the array, and in the third iteration, it becomes the third element of the array, and it gets printed out. Okay, so you can also maybe ask the index. So maybe we want to know the index instead of actually the content. So we want to know the position, and to do that, we can do for index. Now let's maybe do a, okay, instead of I, it doesn't matter, instead of f. So index comma a, and instead of in array, we can do in enumerate array. And this enumerate array will return a tuple which has the index first and then the actual content. And indeed, if you print index right here and then a, you will get the index and then the content, or you can just have the index. Okay, and you can also print just a and then use in square bracket the index to get the value. Of course, array, and get with the index you get the actual value which is contained. So this is the base working of the for loop. So now that we saw how to use these loops within Python, let's see how to do a similar thing in Grasshopper. Why I say similar is because Grasshopper doesn't really have loops. It uses components as loops. So let's see what we mean. Let's just do a list item component, and then I'll drop in a panel. Okay, and then we will define a number. Let's say 1. Okay, let's make it a multi-line data because we'll need it later. Then if I drop it within the list, I inspect the output, and I hover with the mouse on the icon. You will see that at the bottom part of this yellow card that popped up, you see this component ran once. If we go here and say 1, 2, 3, 4, or maybe let's use the same example as before, so apple, banana, and kiwi, you'll see that you get, well, apple in this case, because it's index, and again, the component ran once. But if we specify more than one index, so 0, 1, and 2, and you drop it in index, you will have both 3D results printed out. And if you go on the icon, you will see this component ran twice. So this means that this actually did a loop. It took the list, and if you only provide one index, this component gets executed once, and you get one result. But if you provide more than one index, it will, in this case, we provided 3 indices. This runs 3 times because we provided 3 indices. If we provide 2, this will run 2 times, so twice. So this is how a loop actually works in Grasshopper. You don't actually have a loop, like you can't force a certain amount of iterations using an actual loop component, but what you have is at your disposal the fact that you have lists, and once you have lists, this will trigger the execution of the component that dropped in for multiple times, and this is how loops work. Since we already saw also data trees, this also works on data trees. So let's define a couple of data trees to see this example, because we didn't mention it while I was talking about data trees, but you can do operations on data trees using loops, and I waited because I wanted to explain loops first. And so you can do manage collection. Let's define a tree with one branch which contains three numbers. Let's say the numbers are 1, 4, and whatever, minus 5. And then let's add another branch, and again maybe 2 elements. So let's say 0 and 4. Okay, so we defined a single tree here. Let's see it in a panel. Okay, and then I'll just define another tree. Actually, let's just define another panel. Let's use this same panel as before, 0, 1, and let's try to sum them up. So you can take this, drop it in here, and then this in B, and you will see that the component ran multiple times. In this case, it ran 5 times. But this is because the tree, the biggest of the two inputs, has 5 leaf elements. In this case, 0, 1, 2, 0, and 1, or 1, 4, and minus 5, and 0 and 4. And so this takes each of the elements and then sums it up with the other element. So this is kind of a dangerous way of doing it, but let's just say 3 to all of them, single number, so it's easier to understand. We get 1 plus 3 is 4, 4 plus 3 is 7, and so on. So in this case, this one is summed to each of the leaf elements. Instead, if you do something like 3 and maybe 2, what happens is that you see, let's take the example of the second branch. The second branch is 0 and 4, so it has two elements, 2 leaf elements, and the same for this panel. This is 2 elements. So these two are just summed together like element by element. So 0 plus 3 is 3, 4 plus 2 is 6. Okay, but what happens in the other one, because you're trying to sum a thing with 3 elements with a thing of 2, so what Grasshopper does is that it propagates the shorter one, so this will become 3, 2, 2, and indeed 1 plus 3 is 4, 4 and 2 is 6, and then minus 5 and 2 again is minus 3. Okay, so this is a way to do that. A better way, so whenever you have trees, a recommended way is either you sum things with the same shape. Either you sum single values, so you're sure that what happens, or you sum things with the same shape. So either you have like a situation like this. This is pretty easy to understand what's happening, because all the branches have two leaf elements, so you can understand it. Or you can sum up 2 trees which have the same number of elements. So let's do that. I mean, you can, as we saw, do it also if they're not matching, but you lose a little bit of control of how the sum is working. So what I suggest is actually, whenever summing or operating on trees and having to do operations which take multiple trees as inputs, try to get the trees to the same shape before you do the operation, so it will be much easier to understand what the output it's doing. So I just changed the second tree. I will drop it in, and indeed now they have the same shape, so it's very clear again what's happening. And if we inspect it, it's again ran 5 times, because the longest of the trees, in this case they're both 5 elements, so it's 5 times. So we got a loop of 5 elements. So before we wrap up, let's try to reproduce this example with the example we did before. So this one with the while loop and the random numbers in a Grasshopper as well. So we can define a bunch of numbers. So let's say 0, 1, 2, 3, 4. Okay, so this will be the starting of our loop, and then we can sum a random numbers to them. So let's take this. We will sum a random number. So let's create a random number. Okay, actually we can start with probably a single number and then sum multiple random numbers. Yeah, let's do that. So we'll start at 0 and then some multiple numbers. So this is a range. It's the same as rand int. So we will just define a range which goes between 0 and 70. So we'll do 0 to 70. Okay. And then number is just how many, sorry, I wrote two O's, 0 to 70. And then we get how many numbers we want. Let's say 100, 1,000 even, doesn't really matter. 100 is enough, let's 100. Okay, so we'll drop a number in here. And then we get a list of random numbers. We can round them just because. Let's round them so they're integers. All right. So we get an amount of random numbers. And then we will do just, we'll drop it in here. We will sum them together. Okay. And then what we can do is we have this list of random numbers. We can check whether they're less than a certain value. In this case, we did 50. So let's try to check that. If they're smaller than 50. So if this is smaller than 50. All right. And what we will get is a list of true and falses. So let's see that. Okay, and this is false in this case immediately, so it already breaks outside of the loop. We can change the seed of the random numbers to change which numbers are actually displayed. So let's try to change it so that the first one becomes true. There it is, 39, 7, 35, up until the fifth element, they're true. So here they are, and then false. So what we want is to get now the list of the elements up until we get the first false in the list. So to do that, we just go member index. Okay. And then we take this one. This is the set of numbers, and the member we want to look for is the Boolean value false. If you are not familiar with these components and lists, go check back the video on lists. Okay, so we get indices, and what we care is about is the first index where we get false. So this index with index 0, and is 5, which is what we expected, this false value. And then we can split our original array. So let's take split at index 5. And what we want to split is the list we got here. All right, let's drop it in. And if we inspect it, we can close this Python. It's just in the way. We indeed get the list up until the element is greater than 50. And of course, if you change then the seed that generates the random numbers, you see you have a different amount of numbers each time. You don't actually have to use this this plus. I just did it because I added it in Python. It's actually a better idea to use a merge in this case. So let's merge this array with this 0 number. Okay, let's do that. And you see that 0, it's not merged with the others because they have a different path. So let's entwine it. If you're not familiar with this entwining operation, go check back the video on data trees. Okay, and then we have it here, and now we have 0, so that every time we drop in this one, we will never get an empty list, no matter what is the seed. We always get 0 at the start, as we did in Python, and then here if you change the seed, you get the same results as you got in the while loop. So these were loops in Python and Grasshopper. I hope you found it useful. If you did, leave a like, follow the channel, and see you next time. Bye.